Okay, let's get started. So I believe that we're at this inflection point for Ethereum scaling, and in particular, I have conviction that we will enter a gigagas era for the L1, and specifically, I mean 1 gigagas per second, which if you have transactions that consume 100,000 gas on average, that's roughly 10,000 TPS. And the key unlock for the gigagas era is ZKVMs and real-time proving. So in the first part, I'll talk about what it takes to turn the L1 into a zkELone and what really that means. And then I'll focus on the engineering marvel that is real-time proving that really unlocks this transition. So to have a zkELone, you need ZK execution layer clients and validators. So the basic idea is that as a validator, instead of having to download and execute the blocks, I just verify snark proofs and I check data availability with data-related sampling as opposed to having to download the blocks. And so really what ZKVMs do is that they solve this dilemma of scale and decentralization. We really can have both very large scale and best-in-class decentralization. So the rough goal that I have in mind and various other people have in mind at the Ethereum Foundation is to scale the L1 3x per year. So Tomasz has this number that he shared internally, which is 300 million gas by the end of next year. And Dankrad has this EIP, which proposes to do 3x per year for a period of 4 years. And basically what I'm saying is, why stop at 4 years, right? We can just do an extra 2 years and basically push the limits of the EVM and reach this gigagas per second era. So this is Dankrad's EIP 7938, and basically the idea that basic idea is that the validators will automatically vote for a new higher gas limit following this exponential schedule, and this would give a certain sense of predictability for those who want to build on Ethereum over the next 5 to 10 years. And also, because it's this exponential growth, it's also very ambitious. Now, not only can we grow the L1 by orders of magnitude, but we can also improve the decentralization of Ethereum. So the current meme is that you can run an execution layer client like Gef or Ref on a Raspberry Pi. Well, I'm taking this meme to the next level, which is the Raspberry Pi Pico. The Pico is a $7 device. It consumes 1 watt of energy, and it's sufficient to have a fully validating node on this machine. Basically, you just have to download and verify the proofs, which takes only a few milliseconds. Now, some of my personal goals for this year are, 1, to get rid of my external NVMe drive and run my validator statelessly by verifying proofs of validity as opposed to having to download the Ethereum blocks. I also want to try the Raspberry Pi Pico. If you want to help coding this, I'll run it on my validator. And I also want to, from home, prove the entirety of Ethereum in real time using a cluster of GPUs. Now, in order to really unlock the full potential of ZKVMs, we need this thing called delayed execution or delayed proving. And the basic idea is that between 2 block proposals, block N and block N+1, there's time to do the proving. So the proof for block N can basically arrive just a little bit before the proposal for block N+1, and you can use all of this time as active time for proving. And this is where the real-time proving meme comes from, that you need to be able to do proving within 1 Ethereum slot. And if you want to learn more, there's an ETH research post about this. Now, scaling the L1 is not just about scaling the validators and the wallets and the includers that come with Fossil, but there's all sorts of other actors in the ecosystem. So there's block builders, there's block explorers, and RPCs. And traditionally, the primary bottleneck for scaling has been these weak and unsophisticated nodes. Like, we have such a high degree of requirements for these decentralized nodes that has been the main bottleneck for scaling. But going forward, because we have this solution of Snox, what I expect will happen is that the bottleneck will shift actually to these other entities. And the good news here is that these entities are much more sophisticated, they have more resources available, and the solutions are traditional engineering solutions, just traditional database stuff and networking stuff, unlike the moon math that has been unlocked by the ZKVM teams recently. So just to give you one example of this kind of boring traditional engineering, Geth is using LevelDB, which is a database from Google, and Ref is using MDBX. And these are like traditional things that databases that are useful in all sorts of contexts. So, B trees or LSM trees, if you're familiar with those. And what we're seeing now is that there are databases that are custom built for Ethereum, specifically the Ethereum state tree. Coinbase Base has a database. It's still private, but maybe if you DM me, I can try and help you get access. But a few days ago, Layer 0 announced QMDB, and both of these databases are, roughly speaking, an order of magnitude 10x faster than the state of the art. So I think we need to be migrating away from these legacy databases to new ones. Okay, real-time proving. This is the key thing that was considered to be essentially close to impossible a couple years ago, and now we have 4 different teams that have achieved it. And it's a very, very hot topic, including at EthCC. We have 7 talks today about zkVMs and real-time proving, which is really cool. So Succinct made this big announcement a few weeks ago, and they had this really nice animation on realtime.succinct.ayz. The website, unfortunately, is no longer active, but I think they'll turn it back on soon. We have RISC-0 that is aiming for real-time proving in a garage. So they're building a cluster of GPUs on premises in their offices and trying to do real-time proving there. And just today, Zisk made this amazing announcement again of real-time proving. And I can see there's this team all in green there in the audience, which is very recognizable. And Airbender also had this massive announcement where they have truly excellent performance, and yeah, they're basically very, very close to real-time proving as well. And the cool thing is that 3 of these teams here, RISC-0, Zisk, and Airbender, have fully open source and permissive licensing, specifically for the prover side of things, including the GPU acceleration and the multi-GPU cluster orchestration. Now, proving is a one-of-n assumption, meaning that we just need one entity in the world to do the proving in order for the proofs to be generated. But because we care so deeply about decentralization, we want the n to be fairly large. So in particular, we don't want to depend on data centers. Why? Because there's only about, let's say, 100 data center operators in the world, and n equals 100 is not great, especially if the barrier to entry is to build a data center. So one thing we've observed is that millions of people, tens of millions maybe of people, have electric cars, and that is something that can be done at home. So the guidelines that we have for real-time proving is a maximum of $100,000 of capex for the cluster, and at most 10 kilowatts. So this Tesla home charger is rated at 11.5 kilowatts. And what we find is that the bottleneck is actually the power, not the cost. So if you purchase a GPU cluster for 100K, it will more likely than not consume much more than 10 kilowatts. Okay, so what I think will happen over the next few weeks and months is that the notion of real-time proving is going to crystallize a little bit more and formalize. And here's a kind of a first draft of what we need in order to really take Ethereum to the next level. So of course, we need the latency to be very, very low, a little bit less than 12 seconds, 10 seconds for 99% of mainnet blocks. And we need the capex and the power to be limited. And we also need the code to be open source for the prover. And on the verifier side of things, we also have some requirements. For example, the security needs to be high enough, at least 100 bits of security. Proof sizes need to be reasonably small, et cetera, et cetera. Now, let's focus on power, because that is really the bottleneck. So kind of state-of-the-art RISC-V execution runs at about a gigahertz, actually a little bit more, 1.5. That's what the ZIS team has achieved. And like roughly speaking, the order of magnitude is that this executor will consume 5 watts, right? It's like enough power to for the CPU and the hard drive that will hold the Ethereum state tree. And then you basically need a cluster of GPUs to keep up with the execution. And roughly speaking, state-of-the-art GPU proving, for example, from Airbender, achieved roughly 10 megahertz per CPU. So you need 100 CPUs. Each CPU consumes 100 times more than the executor, so that's a total of 10,000 x overhead to do the proving from a power perspective. Now you may think, okay, 10,000 x is terrible, right? But I see it as a great opportunity to improve. It means that there's more juice to be squeezed. And in particular, my, I guess, guess talking to many of the teams here is that there's at least another 10x from software improvements, and there's another 10x from hardware improvements, specifically SNARK ASICs and things like that. And if that's not enough to get to the scale that we want, we have another trick down our sleeve, which is multi-premise proving. So we can have collaborative proving across different clusters. So for example, me from home, I can collaborate with someone else. And even though we single-handedly we don't have enough power, combined we have enough power to do the proving. Now, one of the amazing things is that we've seen in the last few months an absolute blossoming of ZKVMs. So here we have 10 ZKVMs that can prove Ethereum blocks. And proving an Ethereum block is, quite difficult to reach that level, partly because you need to have a virtual machine and an ISA which is flexible enough to prove it, but also you need all of the continuation and recursion infrastructure to take these big blocks, chunk them into much smaller statements, and then glue everything back together with recursion. So massive congrats to these 10 teams that have achieved proving of L1 blocks. And there's another 9 that are aiming to achieve the proving of L1 blocks this year. And within these 19 teams, all of which, by the way, are open source, we have 13 that are aiming for real-time proving, or have either achieved real-time proving or aiming for real-time proving this year. And so by the end of this year, what I'm expecting will happen is that we'll have at least 10 ZKVMs, and that is amazing diversity. And by the way, this diversity is important for security reasons, because just like we assume that every single execution layer client and consensus layer client is buggy, which is why we emphasize so much on client diversity, we have the exact same strategy for ZKVM. So more likely than not, every ZKVM has critical bugs. But if we have a diversity of ZKVMs, then that gives us some amount of robustness. Now, this is my last slide. If you're not familiar with this website, it's basically trying to provide legibility into ZKVMs and their performance, the cost in dollars and the latency in seconds. And right now, we're basically encouraging the various ZKVMs to submit proofs for 1 in every 100 blocks. And we have this kind of mini block explorer. And there's also these pizza slices, which might be reminiscent of L2Beat. And actually, in some sense, the mission of ETH proofs is to be the L2Beat of ZKVMs. So that's it. I've negotiated with the crew for an extra 5 minutes of questions because I'm the last speaker. So feel free to shoot ahead. And yeah, looking forward to your questions. Any questions? Do we have a second mic?
I will bring it back. Yeah? Oh. How does this relate to the beam chain?
Okay, great question. So the beam chain is dedicated to the consensus layer. there is snarkification there. So we do want to snarkify in real time the entire consensus layer. But in some sense, it's a separate layer and therefore not related. There are some definite synergies. So one of the synergies is that the same tooling, the same zkVMs, can be used for both layers. I guess one differentiation between the beam chain and the execution layer is the amount of resources necessary to do the proving. So for the EVM, we're capping ourselves to a 10 kilowatt cluster, which is quite a lot of power. For the beam chain, what we're aiming for is a single laptop CPU to be able to prove the entire consensus layer in real time. And the reason why we can achieve such low proving resources for the beam chain is that we can make it extremely snark-friendly from day one. So we would use snark-friendly hash functions like Poseidon and snark-friendly signatures that are hash-based as an alternative to BLS. BLS is extremely snark-unfriendly. So by swapping BLS for something post-quantum secure, we also gain at the same time snark-friendliness.
Yes, just a question. If you can comment a bit on how reducing slot times affect this, because you have shown a delta like 2 seconds when you formalize what real-time proving is. So yeah.
Yeah. So fantastic question. When you do the proving, a lot of the components are either like massively parallelizable or take linear time with the amount of work. So if you do the initial execution, which is sequential work, that is linear in the gas used. So if we reduce by 2 the slot duration and also reduce by 2 the gas limit, then the execution doesn't change. All of the parallelizable stuff, that also doesn't really matter. But one of the things that we have is kind of this logarithmic overhead to the proving. And there's 2 components. One is that when you take your block and you split it into chunks, you have to basically recursively take the proofs in order to have a meta proof. And here you have basically a binary tree, and the depth is log n. And here basically when you decrease the total amount of leaves, you're only reducing by 1 layer, and so you still have this overhead, which is kind of annoying. The good news is that the Zisk team today made this, in their presentation, they showed that the recursion is just extremely fast. The latest numbers is like 150 milliseconds for a 2-to-1 proof folding. And I believe they can also do multiple recursions on a single GPU. Maybe the number is something like 16. So this part here is actually not too worrisome for me. And then the other component is the gossiping of the proof. And that is also logarithmic, because when you have a gossip peer-to-peer network, you basically you connect to some peers, and the other peers also connect to other peers, and you have this exponential. Anyway, there's like overhead to gossiping, and that's maybe on the order of 1 second or half a second or something. So if we start reducing the slot durations too low, then that's suddenly like the gossiping time starts to dominate, and the recursion time also dominates. But right now, with 12 seconds, there's a lot of room to go down to 6, which is the proposal. Yeah.
Yeah. So on Twitter, I've seen, for example, Nethermind and some other clients reaching 1 gigagas. And I was wondering, do you think with the current hardware, it will be possible if we run those clients?
Yeah, great question. So one of the things that the execution layer client devs have been doing is launching perfnets. That stands for performance testnets. And actually, this is, I believe, a screenshot of Nevermind. And not only have they reached 1 gigagas, but they've actually reached 6 gigagas on that screenshot. And the EVM is being pushed to extremes. We saw the layer 0. they're claiming 1 million transactions per second, which is kind of completely insane. And so I think, you know how I said that there's these two different buckets of engineering. There's the moon math with the snarks, which traditionally was thought to be impossible, but that actually is no longer the bottleneck. What I expect will happen when we grow 3x per year, like the ZKVMs improve 10x per year. Like 3x per year is like child's play. But for the traditional engineers, like improving databases at 3x per year, that's much, much harder.
Oh, okay. With this diversity of zkVMs, like how we're gonna basically choose which zkVMs kind of qualify for being accepted to produce proofs in Ethereum? I suppose there will be some kind of qualities, maybe, I don't know, the size of the proof, like how long it takes to generate this proof, maybe post-quantum security, maybe what kind of aspects of zkVMs you can look for to kind of be accepted, for zkVMs to kind of be accepted to be as a real-time prover for Ethereum?
Yeah, that's a great question. I basically try to kind of list out the requirements here. These are soft requirements in the sense that every validator, ultimately, every operator can do whatever they want. But I think the thing that makes sense from my perspective is to have client diversity internal to an operator. So traditionally, the way we do client diversity is that it's across the operators. Like I run Gef, like you run Ref, and some other guy runs something else. But here with proofs, it's actually very cheap and easy to run multiple clients on one device, just because each proof takes a few milliseconds to verify, so you can verify 5 of them. So you can imagine a setup similar to Vouch. I don't know if you're familiar with Vouch, but Vouch is basically this institutional tool where you can run multiple clients, for example, 3 of them, and if 2 out of the 3 agree, then that is your canonical view of the chain. Now, I think what would be nice is that there's some sort of like soft, rough consensus around what is this list of clients, of ZKVM, sorry, that are used to verify the proofs. And once we have this convergence, then it means that you know, things simplify. So for example, the gossiping simplifies and the proving simplifies. And so in my mental model right now is that we would want to kind of soft agree on 5 of them and have a 4 out of 5 rule, for example. And yeah, it's going to be interesting to see, you know, which 5 could be selected. What I expect, so one thing that I didn't mention is that not only do we want diversity at the ZKVM level, but we want to retain the diversity of the execution layer clients. So one way to do it is to pair one ZKVM with one execution layer client. So for example, you could pair like Zisk with Gef, and you can pair RISC-0 with Ref or something. And the way that I would do the pairing is that I would have the fastest ZKVM with the slowest execution layer client, so that when combined, you kind of have an average kind of a real-time prover. And so what I would do basically is pick the 5 fastest ZKVMs and pair them with the 5 existing execution layer clients and hope that this average it out to under 1 second of latency.
Doesn't it become an arms race that you're scaling the execution layer, that you also now need to scale the proving, and the proving is already at a 10,000x overhead, and even with 10x on hardware, 10x on software, that's 100x, and you also have to basically include another overhead for scaling the execution layer in this case, right? So because the proving time will essentially increase if the execution layer performance also increases, right?
Okay, so there's a lot to unpack here. Let me address your very last question, which is, when you increase the gas limit, does the latency increase? And the answer is no. And I have to go to my extra slides to answer this technical question, which is this. So there's a fantastic EIP called EIP 7825, which caps the amount of gas used per transaction. And this is landing in Fusaka this year. And the cap is 30 million gas. And the amazing thing with this EIP is what I call sub-blocks or mini-blocks. So you can take a big Ethereum block and you can chunk it into sub-blocks at transaction boundaries. And then you can do the execution, which is the sequential part of all of these sub-blocks in parallel. And so you can have enormous blocks, but because you can chunk at transaction boundaries very easily, it's not going to affect the latency. And actually, SP1, when they announced SP1 Hypercube, that does the real-time proving, they used this trick in order to get under the 12 seconds. Now, your other question was related to the fact that, yes, where we are versus where we want to be is roughly 600x. So we're at about we're at exactly 1.5 megagas per second right now, and we want to get to 1 gigagas per second. So that's roughly a 600x. Where do we find the 600x? Now, I think there's at least 10x from software, at least 10x from hardware. So but the hope is that it's more than 10x. Maybe it's 20x on hardware and like 30x on software. But even if we take the worst case scenario where it's only 10x and only 6x, it's only 10x on both software and hardware, we would be off by a factor of 6, right? Because we've got 10, and we need to get to 600, so we're off by 6. Well, we just need to do collaborative proving across 6 different premises in order to reach that.
Hi, Justin. I see a lot of talk about RISC-V. Does that mean we're like switching from EVM to RISC-V?
So at this point in time, where the only thing that we're doing is increasing the gas limit, you can use whatever ISA that you want. And actually, you can see that some people are using standardized ISAs like MIPS and WASM. Some teams are actually like hardcore rewriting the EVM using circuits and kind of low-level programming languages. So that's what Linear and Kakarot have done. And then there's a few teams out there that have like exotic ISAs, which mean that the tooling is not there to have compilers from high-level implementations like Ref all the way down to this new ISA. But having a diversity of ISAs is actually a great thing in the short term. Why? Because a lot of this tooling is dependent on LLVM. So LLVM is basically this compiler framework that allows you to take high-level languages and compile them to things like RISC-V. What if there's a bug in LLVM? Then now, like all of these ZKVMs are affected at the same time. There's correlated failures. So having a diversity with things like Linear and Ref and Maiden and whatnot, that's actually really helpful. Now, if you're willing to think on a longer time frame, let's say 3 to 5, 6 years, then one of Vitalik's idea, which I really like, is that we could enshrine a new ISA that's ZK friendly under the EVM. And the current proposal, I guess, is to use RISC-V, even though we're looking at everything else. And there's several advantages to doing that. One is performance. So you would allow smart contract developers to access RISC-V directly without the overhead of the EVM, and you might get a 10x improvement. So you'd be paying 10 times less gas in order to make use of Ethereum. And the other cool advantage is that you dramatically simplify Ethereum, right? All of the technical debt that Ethereum has, the EVM has, is basically it dissolves, and now you just have to maintain RISC-V, which is super simple and largely unchanging and immutable.
If we're going to switch ISAs, why wouldn't we switch for one that actually you can buy hardware for today, and you can run it at hardware speed like an ARM?
Yeah, so the two main ISAs that we use in practice today are x86 and ARM. Unfortunately, neither are like permissive. So every time you want to do something with those, you have to pay licensing, and it's just not part of the ethos. The other thing I'll mention is that x86 and ARM are both actually very complicated ISAs. Like x86 is extremely complicated. Like I don't know, hundreds, if not thousands of opcodes. And ARM, even though ARM is kind of marketed as RISC, is actually a CISC, like a complex. It has many opcodes nowadays. So I don't think the ZKVMs would really enjoy implementing either x86 or ARM. But the other thing I'll mention is this. So if you had asked me 2 months ago, what is like one of the main bottlenecks for proving, I would have told you the execution is the bottleneck, right? Because there's this sequential thing that you have to do, which is generate the minimal trace. And that's much slower than running a CPU. But one of the big breakthroughs of the ZIS guys is that they've accelerated that to almost native speed. So 1 gigahertz is like roughly within a factor of like 4 or something, within native speed. And so there's less of a need now to go build custom SNARK ASICs that will handle the execution.
We're running out of time, so we take one last question. Thanks.
How do you see this ZKVM roadmap affecting the L2 space? Do you think this is conflicting with the current layer 2s, or do you think it's complementary?
Yeah, fantastic question. So having the L1 be like a very powerful chain will definitely have consequences for the L2s. My hope is that it's very beneficial for the L2s. One reason is that it's going to lead to much more TVL on the L1, and that will mean that the L2s will basically benefit from this very rich and vibrant hub. One other thing that I hope will happen is that the fact that the L1 is so economically strong is going to incentivize the L2s to adopt the same sequencer as the L1. Because when you have 2 chains that have the same sequencer, you can unlock what's called synchronous composability and like these very interesting network effects. And with real-time proving and shared sequencing, you do have you do have synchronous composability. And then the other thing that I'm hoping will happen is that just having a very strong L1 will be like net positive for Ether, the asset. And what tends to happen in practice is that the L2 assets, the tokens, are very much correlated with Ether. And so if Ether does very well, I expect all of the L2s to also do very well.
Second quick question. Do you maybe have a favorite ZKVM?
Do I have a favorite ZKVM? I have a set of favorites in my mind, but no one specific favorite. One of the things that's really amazing is that a lot of the teams are doing different things. So if you look at Succinct, for example, they introduced this innovation of the sub-blocks and the mini-blocks. Zisk, they did the executor. Airbender, they have this GPU prover that just maxes out the resources on the GPU. You just can't go any faster. They have like really hardcore GPU engineers. And one of the unique things that RISC-0 is doing is that they're building a cluster in their offices so that they can do on-prem proving and like improving the orchestration of multi-GPU proving. And when you combine all of these ideas, you get something which is going to be like really monumental. And so, right now we can do, so Succinct did real-time proving on 180 GPUs. Zisk, I believe, was like 50 or 64, I forget. But RISC-0 believes they can do 16. When you combine everything, I'm hoping that we can do real-time proving on like 6 GPUs or something ridiculous. And I think that will be a very glorious moment for Ethereum. Thanks.